Uh, am I audible right now?
Yes, sir.
Okay,
Yes,
so
sir.
and my screen is visible, right, to all of you?
Yes, sir. Visible.
Yes, sir.
Okay, so let's do a summary first. I think many of you are saying to do a summary for week 5. So first of all,
Yes,
how
sir.
what the quiz like? How was the quiz? Is that fine?
Yes, sir. Awesome.
Yes.
Yeah, but probably by tomorrow I will try to upload the solution. It have been written, but remain review. Okay, so
Sir, there was a question of two lines with intersection. Can you just
mhm.
how to find the intersection of a two line? Means the point x, y.
So just solve it. That is just solving the two equations.
Means substitution each one of.
Yes, any one of the variable you can substitute with the changing in another variable. Like if it is a x plus y is equal to 5, you can take as y is equal to 5 minus x and then substitute in another one and solve that. Okay, and then once
Okay.
you substitute in another equation, you will get a equation in one variable. You will solve for that for one variable. You will get the value of x, and then back to the again substitute in the previously y is equal
Excuse me,
to.
sir.
Sorry, yes.
This class for revision session, your coaching solving.
This is not a revision. This is for week 5, and we'll try to do a summary for week 5. Okay. And week 5. So let's start the session, and let me first do the summary. Summary will not take much time. It is just talking about the exponential and inverse composite and inverse function. Okay.
Okay, sir.
So let's do. It will not take much time. Then I will take you down.
Okay, sir.
Sir, I have a doubt in activity 5.1.
Okay. So will that be okay if I will first do the summary?
Okay, sir, no problem.
Yeah. And then I will take you down. Okay. Okay. So in week 5,
Excuse me, sir.
yes, yeah, hi.
Sir, in case 2, week 1 to 1, week 8 question is asked.
Uh, the quiz 2 is for from week 5 onward to till week 8. But yeah, I will. There is not COT means COT in the sense of it may use the concept of week 1 to 4. Okay, so
Okay, sir.
that is the possibility. But yeah, the question particularly of type of the question you may see for 5 to 8. But yeah, the concept may use like sometime in calculus you are dealing with the polynomial. So
Yes, sir.
it could be possibility. So concept may be used in of the concept of week 1 to 4 may used in the quiz 2 questions.
Thank you, sir.
Okay, so in week 5, the first thing is the 1-1 function. What is 1-1 function? So there are two tests, vertical line test and horizontal line test. So the vertical line test is, let me tell you what is a vertical line test. Vertical line test is not for it is just to check. Suppose all of you gone through the relation, no? Relation. So relation can be particularly like
Yes.
such kind of relation. Like suppose I am making a relation like uh, uh, suppose yes, kind of this one, x or x and plus minus or plus minus x square on this is x belongs to or This is a subset of R2. So this relation, no, this is a pairwise. This is a pairwise or differently. Okay, here is plus minus means the term 1 by 1 will come, like for suppose you are substituting 1 here, so it will be first time it will come as plus 1 square, and then second time will come 1 minus. This is the kind of meaning of this relation. This relation is exactly this one. Like if you are substituting 2, so first it will take the plus sign, so this will be plus 2 square, and then another one is 2 minus 2 square. Okay, this is a kind of relation you have. So similarly for other. So if this is a relation, so we can draw this relation. No? So we can graph like this is of R2, so this is x-axis and this is y-axis. Each point can be plotted in the coordinate system. So here is, this is 1 1, this is 1 minus 1, this is 1 1, this is 1 minus 1, and this is 2 2. There is somewhere 2 2, 2 and 2 4. 4 is somewhere. Suppose this one is, here is 2 minus 4, somewhere point is like this. So if you see that the graph will be similar to this one will go. So in the continuous form, the graph will be like this, it will go. So this relation, so vertical line test is to check the relation is a function or not. So vertical line test, you can see it here, we can easily see that vertical line test is to check a relation which is in graphical form. Okay, which is a graphical form. This relation we can present in the graphically here in graphical form to check a relation. Okay, this will be in the bracket. Graphical form is function or not. So we'll check the vertical line test is to check it is a function or not. So if you suppose see that, if all of you remember the definition of function is that for one input you will get a unique output. So but here is the case is you are one input, you are getting two different outputs. So this is the input set, the inputs you are taking, and two different output you are getting. So that's mean this relation, whatever I took this is not, this relation is not a function. So vertical line test is to check graphical relation would be a function or not. That's all. Vertically I am drawing a line. So any graph, from anywhere it is graph is shown, you just draw a line. Okay, just draw a line. If it is intersecting at two different places to the graph, then it is not going to be a function. And horizontal line. So there is a horizontal line test. So this test is to check one function. First thing is, once it is already saying the relation, whatever it is, whatever the graphically thing will show you, that is already a function. Okay, whatever the graphical picture is given there, that is already a function. You will check that with the horizontal line test, is that graph of the function, or that function is a 1 1 or not. So horizontal, as the name is there. So horizontal means you will draw horizontal line. So for example, I am making suppose this one. So this is a graph of a polynomial. There is a more possibility, no? We have a more. Am I audible clearly? First.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Yes, sir, you are audible.
So there is no. We all of you gone through the polynomial, even the quadratic.
Yes, sir.
Yeah, a quadratic
Yes, sir. Yes, sir.
polynomial of any order, of any degree. Any order mean to say any degree. So we have gone through. So polynomial could be such kind. So suppose in some range it is given the polynomial, and if you draw the graph, so see that what is happening here. See that this line is that it's showing. See, this is the value, no? This is the inputs x-axis and this is y-axis. So these are the input set, and with respect to this, you are getting these are the outputs. the y coordinates in the if suppose this is the point, so this is x and this is y, so this y is the function value and this is the x value, or you can differently you can write this is x and this is f of x. These are the points. So y coordinate is represent the function value. Okay, so these are the function value here. So if you see it here, this vertically line, once you are drawing this, so at here, okay, so just a minute. So this is y-axis, or you can say f of x value is coming here. So see that at here, this is the function value. Suppose this is 3. So this is the 3 for all. It is happening. So here is going to be, suppose this is alpha. Okay, so this is alpha 3. This is suppose beta. Here is beta. So this is beta 3. So what is the second coordinate? If you see that 3, 3, each time you are getting many places at 3. So these are the outputs. So see that for the difference, so these two are the different input but getting the same output. But what is the definition of 1 1? 1 1 says, for if you are giving one input here, okay, one input here, you will get output with the, it will be for each time you will get unique output also. And this is one part. Okay, like it will be never like this, like for two different input you are getting same output. This will never happen. Like here it is happening. Suppose this is alpha, this is beta. This is the set of domain and this is the set of codomain. Okay, this is domain and this is codomain, and here you are getting some alpha and beta, you are getting same output. So this case is happening right in the graphical form using the horizontal. Once you drawing the horizontal, this is the same thing is happening. So this is not for the 1 1 case. So
Sir, I
once
have
you
a general doubt. Sir, if it fails the horizontal lines, then it is not an inverse function, right?
So if it is fail the, so fail
Horizontal
means
line.
what? Fail means it means it is not intersecting at many places, right? That's
Yes,
the
sir.
meaning
Yes.
here. So it is not, that means function is going to be 1 1. That's the meaning. If it is fail, then function is 1 1.
Yes, sir.
If it is passing this horizontal line test, it means
That it is not 1 1.
Sir, fails
not-
means at one place it is intersecting.
So it is exactly convincing me, like it is saying to be like how you are understanding this one. If you are assuming the fail means it is actually not intersecting. This is a kind of passing. No, it is a kind of it is passing the horizontal line test. This is pass. Horizontal line test is passed by this whatever. So if it is fail, then it is 1 1. If you are assuming that okay, pass means it is 1 1. It's totally up to your mind. It is, the question will not ask like the horizontal, the graph is past the horizontal line test. It is not, it is
If it is
exactly
given that
ambiguous, no? How it is.
Sir, if it is given that horizontal line test fails, what does that mean? What's that mean?
Fail
Sir,
means
it's one of the
1 1.
questions in the activity.
So what is
it
so
is
from
mentioned
my
like
side, let me know what
Yes,
sir
sir.
says. What sir says? Can you tell me what sir says? Because he said no in a clear way that if that that graph is horizontal line fail or pass. So all of you gone through the lecture?
Yes,
Anyone?
sir, in lecture
Yes, sir.
it is not mentioned properly, but in one of the activity questions it was there. But if we interpret that question, then there fail means that it is intersecting more than 1 point.
1 point. Yes, sir.
If it is fail, then intersecting more than 1 point.
1
If
point.
it is
Yes, sir.
pass, then that means that is function is 1 1.
Yes, sir.
Yes, sir.
Okay, so let's be continue with this one. Okay, as the activity is there, so it is in our mind. No, it is not saying to be okay. So it is a kind of like okay, passing means function is 1 1. That means this line is not intersecting. So let me write here if it is the convincing way as the activity is going. And already I hope I have not remembered the exact time, but I have seen that sir said okay, it is passed or fail, and for which case sir said. So let's be continue with the activity, and it as the horizontal test pass, if it is, then that means function is 1 1.
Sir, 1 to 1.
1 1 or 1 to 1, whatever we will say. So function is 1 1. So that means this is the test phase. This is case for this horizontal line test is fail for here. It is failing. So this is for fail case. Okay. So let's be continue with the activity. That's why if anyone have remember, I think this is the case. Yes, the activity. Let's be continue with the activity, and pass means 1 1, and fail means that means your line is intersecting at many points. Let's continue with
Right.
this one.
Yeah.
The same way we can saying to be the horizontal also, sorry, vertical also. If it is pass, then means function is 1 1.
So in the lecture, excuse me, sir.
Yes.
Yeah. So in the lecture, it is specified clearly that whatever you said just now, like the horizontal line intersects the graph, in at most 1 point, then f is the function is 1 to 1. So
Function is no. So what is the case sir is saying is that failing, no? Sorry, passing. If it
passing.
is
If any horizontal line intersects the graph of a function in at most 1 point, then the function is 1 to 1. At most 1 point. Yeah.
So the same as passing means
Yeah.
the vertical line test. Pass means that means it is actually not intersecting at two different places. That means that it is the graph is actually represent a function. And fail means not representing a function. Let's be continue with this one. Okay. So this is the meaning of horizontal line test and vertical line test. Now in the next step, exponential. So first thing, what is exponential? Exponential function. Exponential function. What is the exponential function? Like we know, right? We studied about the quadratic, which is a kind of quadratic case is ax square plus bx plus c, where a should not equal to 0 and a b c could be any real number. Polynomial is a kind of this is a n x to the power n to till a0. This is a type of function. So similarly for exponential, for the time being, you can assume the definition of exponential means a function of such kind, a to the power x, where there is a constant here. That's as here, in quadratic, there is a constraint that a should not equal to 0. So similarly here is, let's make a constraint here, and it is a meaningful constraint we will try to create. So let's see it here, why it is a meaningful, that we cannot assume a should. So if a is 0, then there is no meaning. This is going to be the 0 function, a constant function. So let's remove that a. Similarly, negative case we have to remove for a should not be negative. Why it is so? The case is here, if it is you are saying a is equal to -1, as here a is negative now, and if you are assuming x value is 1 by 2. So in that case, your function is going to be minus root of -1, and that is a complex number. And for this course, we are not going to deal with the complex number. So let's make again extra constraint here, that a should not equal to 0. And another constraint is that a should not equal to again 1 as the 0 case. As the 0 case is, again, as it is going to be 0 0, and again it is 1, then again it is going to be a constant function 1. So if we remove this constraint, okay, sorry, so let's keep this constraint here, and now this is going to be an exponential function, and let's make it the constraints that a should belongs to 0, open interval 0 to 1, or so here is you can give the union, or 1 to infinite. This is going to be the constraint here. And this could be a different representation. Hope all you can see it. The how sir is, there is I think different notation have sir given that also. I have given in the set form that a should belongs to 0 to 1 and union of 1 to infinity, because this is going to be the you can say we can take a from here only. So such kind of function you can say the exponential function. Now there is for any case there is two different, like there is a these two sets actually make a big difference here. What is the difference? That in the graphical or behavior of the function, and if you are play with this range, it is it's look like very similar, exactly like structure is the same. And if you play within this range for the a, then it's look like the similar structure. So if a is going to be in this range, okay, then let's see that the graph is, so let's see on the Desmos, that would be good. So okay, so we are taking a to the power x. Here is, if you want to add, we can add slider. So here is for the, see that for the a is equal to 1 case, okay, it is going to be, see the constant function here, and in below, see that in between when we are playing with the 0 and 1, in between 0 and 1, see that similarity. Let me make it a bit smaller in the away from the origin. Let's see it here. Okay, so see that if it is playing between 0 and 1, like till here I am doing it only, see that these are the similarity. If you see that this is going to be the similarity, and now if you I will go beyond of it from 1. So see, if I'm now at 1, it is going to be constant. Now I am going to beyond of 1. So see that this is the similarity, exactly this is the similarity. Even you can say till infinite, it is going to be the same similarity, 1 to infinite. So there are two type of thing, is that first thing is that if it is in this range, the graph of that exponential is going to be like this. And reason is also very clear. Now all of you gone through, no, the polynomial is enough to tell you the polynomial property we have. So why it is so, if it is, why the graph is like this, the reason is very clear. No, if you take a is equal to 1 by 4, okay, and now if I am taking a to the power x, means 1 by 4 to the power x, okay. Now I am giving x value as 1,000, okay, I just give the value 1,000. So what is this number? And again, so suppose I am giving x value is 1,000, and sometime I give x value is 100. Two values I took. So for this case, I will get 1,000, no, and for this case I will get 1 to the power 400. So which number is bigger here? Which number is going to be bigger?
1 upon
4 to the power 100.
1 power 100. 1
Yes,
upon 4 power
1
100.
upon 1 upon 4 to the power 100 is going to be bigger than this one. So that's why I see that if it is x is going to be this side, the number is going to be very smaller. So no need to remember here. Okay, we are not going to remember the graph. We will just know why it is so. And this is the property of the real number. There is nothing, there is not much difference. This is because of property. So as the property we have of the real number, because of that it is happening. So that's why the graph is also the same of this structure. So if it is in this range, the graph will be very similar as just now we see on the decimal. So in this fashion it's look like it will be kind of this one. Either sometime could be like this. So the same structure, either could be some wider, some narrow, Okay, or means here is steep ascent. Okay, is steep descent or descent, not descent. This is a not a steep ascent. It will be wider. Sometime it will be narrow. Sometime. So it's depend on how the number is, but it is the same structure. Now, if it is falling in this range, now the picture is different. So it is going to be in this range. And also, no need to remember the same property of the real number. Because of the property of real number, it is happening. The same way, if you are taking any number, a is equal to, let's take 8. And now function is going to be a power x, which is 8 power x. Now, if you take x is equal to 0, you will get 1. A to the power 0 means 8 to the power 0 is the value is always 1. So here any exponential is always intersect the y-axis here. Okay, at 1 only. At 1 only. Any if in this range, if you are taking any value of a, it is always passed through this point 0 and 1. Because of this property, no, this is the same property. This is the property of real number, nothing more. And the same way, as number is going to be bigger, suppose you are again taking x is equal to 1000 and x is equal to 100. If you compare the 1000 number for x is equal to 1000, the number is going to be bigger. Okay, so that's why it is going to be increase in this fashion. And if it is, just a minute, and if it is okay, and if it is a more bigger number, so it is going to be more steep, fast to grow. As you know, the sensitive case we have seen in the the same way. The more sensitivity is here in increasing. It is a more sensitive as you are taking the bigger number for the case. And that's all the exponential. Now everything is open for the exponential, because the graph is always be the same. Okay, even for even for the natural exponential. So what is the natural exponential? Is the case for in place of a is could be falling in the range I said, but here is a special real number which is c, and e is something 2 point some number is there. That is a irrational number. And if you think about this one, this is an exponential. This is a real number. A is here also, any real number is happening. No, A is here any real number. The same. Actually, this is a special case of this one. And if you see the graph, it is exactly the same. This one. There is not. This is a special. The natural exponential is the special case. Why is specific? Here is especially we are studying. That reason is the natural logarithmic, the inverse of this. So we'll see it here. The inverse is here we are going to study. And okay, so this one we have.
Sir, can you explain this one more time?
Which one? This one?
Yes, sir.
Okay. So here is, so again, let me again to repeat it here itself. So whenever you are thinking it, don't remember the graph. Okay. So for the time being, suppose I am doing, I haven't remember that. Don't remember the graph. If it is a is falling, the exponential we are taking of such case, and if a is falling in this range 0 to 1. So for example, always you can take a is equal to 1 by 2 and think about the exponential 1 to the power x. And now again, assume that x is equal to 1000 and x is equal to 100. And you can easily say that that number is going to be for the 1000 kgs is smaller than the 100. Now the graph, now you can think how the graph now? The graph now will be as the number x value is increasing, the exponential is going to be decreasing. That's the meaning here. This is the meaning. No? As number is increasing, your value is going to be smaller. That x-axis is going to be and play as a asymptote. And if it is the negative case, no, as the negative number is there, the x value is 1 by 2 of negative means 1. So this is going to be the reverse. This is
Sir,
going to be 2 the
voice is
square.
not clear.
Is that to all of you or for you
Now
only?
it's clear. Now
Clear,
it's
sir.
clear.
Okay. So if it is the negative case, no, it is going to be the reverse of it. That means you will get this one, and that's why see that the growth is this side. It is a very fast, because as the number is in the case of not in the factor, it is going to be in the case of a integer case. For the 1 by 2, I am saying it could be any real number. It could be 3 by 4, 1 by 4. For the time being, for the simplicity, I took 1 by 2 to see that. So don't remember the graph. Okay, don't remember the graph. Just take a number and take some number for x, take some number for a, and think that how the graph would be. Okay. So similar to the case for the positive, like positive means not positive for the case of 1 to infinity. 1 to infinity means a bigger number is there. That means that a is greater than 1. And a is greater than 1, and you are taking the exponential of like a to the power some number, and that is going to be a big number. So that's why the growth is like this, you will see. Now there is another thing. Let's and not another, that is exponential thinking like this. So can you tell me how the graph would be for this case, and a is belongs to in this range 0 to 1? How the graph will be? How the graph it would be? It could be exactly this one, or it could be different.
So it will be the mirror image downwards from x-axis.
Yeah, exactly. It is going to be
Yes, sir. Downward.
this side, right? Just small change. Why the reason? Nothing more. Again, if you are taking negative value, means it is going to be positive now. And positive and a smaller one makes it very small if it is falling in the 0, 1. That's why this is the graph. Or even the mirror case with respect to, with respect to which we will take, with respect to y-axis we will take, right? Mirror image, because here is positive x, here is negative x. The same way, with respect to y-axis we will take the mirror image. So if it is this side, so it is going to be this side. That's why if you want to remember by the mirror image, you can remember that. Otherwise, just remember with the function value, as we are with the property of real number. Negative cases, in the case of negative, it is going to be positive now in the negative side. Now make a smaller and smaller in the case of this one. So just think about the property of real number. Property means what? As the number, comparing the number, nothing more. It is just comparing the number, and it is easy to compare because it is in the form of power. Always give the bigger and bigger, or very fast smaller number, or very fast bigger and bigger number. That's why easy to compare with the which number is going to be smaller and larger. The same way if you are thinking a to the power minus x, where a belongs to 1 to infinity, so how the graph will be exactly, think again the same. It is going to be this way. Negative side is going to be very fast growth. So it could be like this, not is it is, if you are making the direction. So I am making a wrongness here, I think. So let's assume that here, if I'm making wrong, so a is equal to 2 and x is equal to, let's take minus 4. So it is going to be what? Minus plus, and it is a big number. And if it is x is equal to 4, then it is going to be negative. So 2 to the power 4, it is so it is correct, right? It is correct. It's look like the same way as it is following 0 to 1 case. So don't remember, take some example, and because the graph is actually very for all value of a in the case of falling in the whatever I give the interval in this ranges, in this interval, this picture is very similar. So this is the I'm now going to discuss the natural exponential. The reason is nothing more. It is a specific number for in this case.
So
Okay.
there is also a topic of increasing or decreasing function.
So this is one part. Okay, this is the part related to the graph. I hope it is a bit clear. Now the cases for increasing. So increasing and decreasing function, increasing and decreasing. So this is just a definition. If you see the definition from the definition, it is clear. So what is increasing means function value is increases. So what is that increasing? I am taking two number. Okay, suppose I have a function from set A to B. I am taking two number from the domain from A. Okay, and this number is obvious. I am taking two different numbers, so it is obvious very much that either it could be x1 is greater than x2 or vice versa. So suppose I am taking this one, x1 is lesser than x2. But when I am taking in this form, okay, like for example, I am taking x1 is equal to 2 and x2 is equal to 3. But the effect on the image, this is a smaller one, which is f of x2. Sorry, so here is f2. Okay, here what this case. This is the case here. If number is in the form of increasing, and this is true for all x. Okay, suppose this is true for all x belongs to A. If you compare the number, okay, I'm taking any two number and they are in the bigger form, like in the order, increasing order, I'm taking the number. The outputs also I'm getting in the increasing form, like increasing means bigger number in the form of outputs is also getting. So f of x1 is lesser than f of x2 as this one, x1 is less than x2. If this implies f of x1 lesser than f of x2. Function values also in compare with the same pattern as here. If it is the same pattern following, then this is called increasing function. Okay. Decreasing is same. Suppose I am again taking two inputs. Okay. And the same relation I am taking, x1 is, I am taking two numbers, surely the numbers would be greater or lesser. Okay. I am taking two numbers here. But this implies f of x1 is greater than f of x2. Okay. See that here is f2. Here is, suppose this is 2 and 3. So this is this one the case. Okay. But the outputs are in the reverse form. See this sign. Okay. This sign as here. Okay. If it is the same pattern follows, then it is increasing. But if it is reversal form, like I am giving the inputs in the increasing order, but getting the outputs in this fashion, decreasing number. So this is for the decreasing function. So for example, it will be here, we can see A is the case for 0, 1. The exponential a to the power x. See that how it is, the graph is in this fashion. So what is happening here? See, this number and this number is, okay, this number is smaller than this number, x1, x2. Okay, the output is what is happening here. This is the corresponding output, no? So this number, this output and this output is what? This is greater than, this is f of x2 and this is f of x1. And this is what is happening, this sign. And what is here? This sign. See the sign, reversal form it is. What it means that this is decreasing. This is decreasing. So this is for any, in this range it is falling. So in this range, it is actually same pattern we have seen and saying to be, if it is in this range, the function, exponential function is going to be always a decreasing function. And if it is falling in this range, so exponential function is again in this fashion. Let's take here and here. This is x1, this is x2. So this is the case we have. And now see the outputs we have. This is f of x1, this is f of x2. The same pattern, see that this sign is the same direction. Here is in the reversal form. And it is in the everywhere it is the same. Okay, it is in the everywhere it is the same pattern. It goes. Here is also the same winding. So this is for increasing. Okay. Is it clear? This is the meaning.
Yes, sir.
Mhm.
Hello.
So, can you
Yes.
please take an example of decreasing function?
So this is the example I took, no? Decreasing is for this case. The exponential itself I took.
Sir, please take values now.
Okay, so here is, this is a particular, suppose I am taking a equal to 2 here. So exponential is 2 to the power x. The graph is going to be the same for any. This is a one particular number. And again, it is in this range is falling, so it is increasing. That's why it is a more general form I took, but this is a particular. If it is in this fashion, I am taking a is equal to 1 by 2. So graph is the similar. If I will draw the specifically graph of here 1 by 2, it is exactly the same as always. This is a rough diagram. If I'm drawing the rough diagram, I don't know how it is going, but yeah, I know the pattern is the same for the negative, for the smaller, when it is falling 0 to 1. The similarities will be occur the same. And now in the case is here, it is decreasing. If I will take a different example like here, suppose I'm taking now a polynomial. No, for the time being, where is that? We have seen many polynomial. Suppose if we will take this polynomial, this one, okay, or even this one, 8x to the power 4. We don't know how it could be. So let me see it here how it could be. 8x to the power 4 minus 2x square plus x. So suppose I am taking this polynomial, okay, and I don't know how it could be, but let's try to draw it here quickly. So here it is going to be x cube minus this is 2x plus 1, and I don't know how it could be here. What is the root we can take? I don't. Let's draw on the Desmos. That would be good. Let's draw on Desmos first. 8x to the power 4. Okay, minus 2x to the power is what? Sorry. What is that? Yes. Square plus x. So see it. Let's see it here. The graph. This is the graph we have. Okay, so
Sir, you are not audible.
Yeah, I am not speaking now. So see that I'm audible right now.
Yes.
So
sir.
here, so here, so these are the, suppose this is the we have. So I don't know how it could be, but so this is a root. We have one root. Suppose this is alpha. This is another root beta. Okay, and now there is two real root in that polynomial. In this polynomial for this polynomial. This one. So see that in this range. See, this is the function we have. So I don't know what is this alpha exactly. Okay, but in this range till here. You can say the polynomial, let's say this is beta we have, okay, this is, let's say alpha prime we have. So x belongs to alpha prime. This polynomial is increasing or decreasing?
Decreasing.
This in this range, it is decreasing. Function values are falling here. This one, then this one, then this one. This is a fall we have. Now, if it is here to alpha prime to beta, there is an increment is here. So again, the polynomial px is, please all of you mute yourself. Px is, if x is falling in this range, it is increasing. So see, this is the increment. As the values, the inputs is increasing, the output is also here is increment is there, and it will go not even the beta. It is again. This is the still increment is happening. That there is a wider thing is there. Okay, this is not, still it is increasing, but increases, what it mean that, what is the difference here or even here in this increment, and what is the difference of this increment? What is here happening? Why this is what is happening here? This increment is fast, this increment is fast, but this increment is bit slow. That means here if you compare the number, the difference will come not much. But here if you take the difference between two number, it will come as a very, very large difference, you'll see. This is the meaning of, that's why this is a wider, it is a wider thing is happening. But yeah, still it is increasing. Okay. So increasing and decreasing is not so see, for example, if you check, if you want to check how is that function is increasing or decreasing, so okay, so just wait, okay, just still wait to the calculus. Now you are in the, already in the portion of quiz 2. So just a minute, okay, just a minute. I will take a 1-2 minute, okay, I will just a minute.
Sir, you are not audible.
So just wait, okay, okay, so okay, just wait 1 or 2 minutes, okay, I will back to there is a problem is there, okay, just wait 1 or 2 minutes, then we'll start again. We already discussed the increment, this increasing thing. I will take 1 more minute, or even I have discussed the increasing thing. Okay, just wait 1 or 2 minutes, then again we'll start. Okay, there is a problem is there. Okay.
Sir, your voice is not coming.
Sir is not speaking.
Okay, okay.
Okay, sorry, just got a call. Okay, so am I audible right now?
Yes,
Okay.
sir.
Okay, so
Yes.
there is a thing, no? Now we are in the already quiz 2 syllabus, so we are studying now in quiz 2 syllabus. So don't worry. So this is one process, no? This is a algebraic. This is a one of the, no, without using the calculus. This definition, this is this definition for why the looking the like with the observation like that the function value. But once you know, once we study the calculus, no. So calculus says that once we know the calculus, and there we'll see already it is in the week 7, 8, and 9. Okay, so we'll see already there. So we'll see, no, we'll see till so quiz 2 is till 8. So yeah, within the week 8 we'll see there that the increase and decrease, or in the function is increasing or decreasing, is once you derivate the function. Okay? And if the derivative is greater than 0 when the whatever the interval is given, okay, in this whatever the interval you are taking, in that case it is happening. So this is for increasing case. And if derivative is less than 0, then whatever the interval, like here is in this interval it is decreasing, in this interval it is increasing, and rest all it is increasing. So interval depend on, so increasing and decreasing, it will follow on the whole real line, or it could be in some part like here, like this one. So in some interval it is less than 0, the derivative is less than 0, in that case function is going to be decreasing. So we'll see here in the calculus portion also, and the calculus is makes the very easy to see increase and decrease. Okay, the function is increasing or decreasing. But this is one, the basic definition is of increasing and decreasing is the only this one. Okay. So this is one part.
Sir,
Sir,
like for a function 1 by x, we cannot define it like an increasing or decreasing function, right?
but
Because
in
it's
some
not
interval
exponent.
we can discuss, no? If it is the whole real number, we cannot, but in some interval we can say it is increasing or decreasing.
So sir, like in one of the activity questions, this was the function and it was asked that is it a decreasing function or not? So what should we do like?
So it's I think there should be, if it is 1 by x is there, that means the graph would be like this, right? Could be like
Yes,
this.
correct. Yes.
The graph would be like this. Now it means that this graph is here, it is similar. The x-axis is going to be asymptote here, this side. That means this side, if you are taking the interval, open interval 0 to infinite, this is decreasing. The whole minus infinity to infinite, okay, minus infinity to infinity, which is a real number, exactly mean to say, okay, it is private form. Okay, so it is mean to say the whole real number. In this case, you are not able. So this is not. Here is the break. No, you cannot. Even this in this range, it is. What is happening here? It is decreasing or increasing?
Decreasing.
Decreasing.
No, why it is so? Decreasing again. It is also in this minus infinity to till open. It is again decreasing. No, function value is again falling here very fast. So it is in this range here is decreasing. So either the question would be in its domain. In its domain. If the question is asked, you have a function fx and consider the function in its domain. So in its domain means you are not considering this one. Now in this case, it is decreasing always, right?
Yes, sir. This case was mentioned, but the option was not correct. Like it was mentioned that it is not decreasing for this specific domain.
So like we are looking here, it is decreasing, no? Am I making a mistake in the graph 1 by x? I think
No, graph is correct, sir. And also like if you go by the method, like x1 is less than x2, and that for f of x1 should be greater than f of x2. That also is true in this case. So that's why I was confused that is it decreasing or not? Because in
Here
the
is it
activity is
getting
not mentioned.
decreasing. And also see, the in other ways derivate the function. So this is going to be minus x square, and it is always negative for all this. So it is a decreasing for all. It's true now with the calculus.
Okay.
So, can you explain asymptote?
Sorry?
Sir, can you please explain vertical
Vertical line test?
asymptote, sir.
Asymptote. Okay. Asymptote. So asymptote is nothing. Asymptote is, for example, I'm saying, suppose 1 by x is I'm taking, or okay, if I'm taking 1 by x, so asymptote mean no, you like here the graph, if you see, this is the graph is going to be like this. So here the x-axis and y-axis is both, it is a kind of asymptote. Asymptote means what? The graph, no, the graph will not intersect at, see, it is, we are till here, no, this is, we are able, in some range we are able to see, but this sign is, this arrow sign is tells you that we are continuously in the same pattern we are following, and it means that that graph will not intersect y-axis here, never. It will be very close, but never will be, never, it will never intersect y-axis. Similarly here, it is the same meaning, arrow sign is there, that means it is following the same pattern, and here is, as there is a gap, means this graph is not intersecting, but it is very close to x-axis. So this is a kind of asymptote is happening. So asymptote means it will not cross that line, which line we are saying as a asymptote. Even for the example, x to the power, sorry, 1 upon x minus 1. So for this case, here is 1. Okay. So thus the graph will be exactly as there is a just shift off with this graph. So this is going to be the same. So here is this line x is equal to 1 is a asymptote here. Why it is? The same pattern it goes when number is increasing or any, what is happening, whatever. This is the meaning of asymptote. It will not cross that line. It will very close to that line, but never cross that line, as goes to larger and larger, or smaller number. This side is a smaller and a smaller number, and this side is larger and larger output. Here is a smaller and a smaller output. Okay, this is the meaning of asymptote.
Yes.
Okay, so this is one part, and now let's talk about the composition. I think this is the one remain part, I think so. And then we'll talk about the inverse quickly. So composition is not so composition, yeah, so composition is if you gone through, I suggest you please watch the lecture, because there sir have taught the tricks how to find the domain of composition. So there is the first thing is that mean to say always the composition is possible always wherever where you are getting the input. With the example, let's see that. Suppose fx is equal to, I am saying x square, and gx is 1 upon x minus 4. And composition, here I am taking composition means f circle g. Here it means that f and then gx, f of g of x. What it mean? That it means here, so here is simply saying to be in place of x, where is x here in gx, sorry, in fx, where is x, just place gx. So let's place here, so gx whole square, and this is going to be 1 upon x. So gx is exactly
minus
this
4
one.
to
So this is going to be square. Now see, this is the getting one composition function. This is the way to get the composition. Wherever x is there, just substitute where is the function, the exact function, substitute that function, and then get the function. But there is a problem with the domain. Here is domain of this one is 4 real number. Here is domain. Here is domain. Here is domain is 4 real number, but you have to neglect 4. The problem 4 is there, that if you substitute 4, you will get a 1 by 0 form, which we don't want. So we are not going to take that. So this is one here. But what is the domain of this composition? Okay. What is the domain of this composition? So here is, finally we got this one. Okay, we got this one function, the composition function here we got, which is again from after looking this one, the domain you will say again r minus 4. That element, there is the problem. But this is not always true. Okay, this is not always true. Because once you see it here, you will whenever you are taking this domain of the composition, you have to see this one and then decide the composition. Domain of the composition. Not after the just getting to what is after composing that one, and you are whatever you are getting the final function. While looking that, you cannot say, because you are see, this is not our function. Our function is the composition function. So according to this one, we will decide our domain, not exactly looking the function and then say that the domain is this one. According to the composition, we will decide the domain. So here we are taking g of x, and here is x square. So for the x, the output here is domain is any real number, and gx, the output. So here we will see the range of now. The range of gx we will show, no? We will see it. Because in gx, whatever the outputs you are getting, that is going to be the input for f. Okay. So here that's why you will see the range gx. So range of gx is the whole real number is going to be, right? So here is we have to see the range here. So here the range of gx is going to be the whole real number. And already fx took the whole real number as a domain. So there is no issue with the saying to be the domain of is the same. But think about the reverse form. So there is the issue we'll see here. We'll see here the problem. So let's talk about the g of f of x. So here is going to be this one. Okay. And this is, so where is the x? Place exactly fx. So here is g is over here. This is 1 upon fx minus 4, which is we got here x square minus 4. Okay. Now, while looking this one, you will say the domain is what? R minus. You will remove 2 number. Sorry, here is going to be minus 2 and 2. You will remove this 2 real number. But this is not the case. Again, we have to see with the domain with respect to the composition. So let's see here the composition. So here fx is our x square. Okay. Fx is here our x square. Now the outputs here will again see the range. Range of fx is again, what is the range of fx? The range of fx is always positive. And not even positive, the range of fx is 0 to infinity. Even you can close 0 side. This is going to be the range because our function is x square. Okay. So we'll see here the range now. Then this range is going to be input for gx. Okay. Now gx have problem at 4. And one thing is there, so and we are getting, so actually the same we are going to be we are actually the same also we are getting, but actually so here is the problem that we are going to be the same domain while looking, but it is not always true. We have to take some different example, then we will able to see, but this is not always true. So here is at, so gx have problem at 4, and from 4 we are getting from x square how many places when we substitute 2 and -2 both. So that means from this composition we have to remove that 2 and -2, so that we are not able to get 4, and there is no issue with the, it will not create problem for G. So that's why finally the domain is again the same is here going to be, but we have to see very carefully that we are not going to take that input which create problem for Gx. Even for fx that is going to be true, but we are not going to take that as a input, because once we are getting output that will create problem for G. So we are not going to take that input, and we will remove that. And finally the input will be after doing, suppose there is a problem, for the time being assume that there is a problem for Gx is 1 at 1 also. Okay, for Gx there is a problem at 1 also, so 1 we will get from fx at 1 also. Okay, but for 1 is going to be the domain for fx, so it will be for 1 is going to be in the domain of fx, but when at 1 we are getting whatever the output, that will create problem for G, so we are not going to take that. So finally the domain will take, the final composition domain is going to be after removing 1 also. That's the here difference between the normal function and the ones you are taking composition. Okay, is that clear what I am saying? You have to,
Sir, one question, sir. Actually, a perpendicular related question, sir. So 2x plus 3y is equal to 2, and
no, I am saying here. So forget about this one. This one I am talking. Let's finish this one, then we'll talk about the perpendicular problem.
Okay, sir.
So whatever is this we talked now, is that clear? When we are going to take?
Sir, excuse me, g of f of x and the f of x, g of f of x, then the value of put in the g of x, f of x, and find the value of range and domain.
So I'm okay. So I mean to say whatever I said, is that clear to all of you? And for all of you, I'm saying.
Sir.
Okay.
Sir, can you repeat how you got 1?
So not got, I didn't get 1 also. So you didn't listen properly. So I said that assume here. This one is assuming. This is not true for our example. Okay. So that's why I'm saying that's why I'm stopped here and say that what I mean to say is that all of you are getting or not. Assume, I said assume, and you didn't listen that. I said there is a problem at 1 for Gx also. There is no problem for our example. There is no problem at 1. The problem means here we are not getting in denominator at 1 as 0. But for the time being, I said that there is a issue, there is a problem at 1 also. Then we are not going to take as a input where we are getting output as a 1. That's why, so forget about you are getting. So that's why listen properly when I were discussing this one. This is not for our problem. This is I took additionally, and then after assuming this one, and then I said that this is happening.
Okay, sir.
Sir, can you take doubts other?
Yeah, now almost done. We are done. Only the inverse part is remain now. Only let me finish that, and now the doubt I will take. So only 2 minutes will take. So inverse is what? Inverse is nothing but the same composition is there, and nothing more. Inverse is what? Inverse is just, suppose you have a function fx. Are we able to get a function gx such that when we compose these two, we'll get identity function, means exactly input that x in the from the both side, mean to say even the one side or both side. For the here This is both side means we are taking here. For this course is that one side if it is true, then both side will be true. But once you will know, once you will study in maths, pure algebra portion, there is a differ. Okay, but for here, for this course, if one side is happening, that's enough to say that is inverse. So this is a inverse. So composition once you are taking, are you able to get exactly a function gx such that once you compose these two, you will get identity function. If it is such there, so that gx is your inverse function. So for example, I am saying, suppose fx is equal to this x minus 4. What is the inverse of this one? So there is a way, no? Already it is a tutorial which Srikant have taken. Okay. So please, my suggestion is go through this tutorial. This additional tutorial is there that, I think resource from instructor, I think so, in this here. This is one important, and Srikant were telling you how to get how to find the inverse. So to find the inverse, this is the way to, this is going to be f of x, and this is x minus 4 is there. And this is x is equal to 1 by f of x plus 4. So finally, this tells you that assume at place of f of x is y, or even say to x, okay, and this x is going to be, let's say, gx. So finally, inverse is going to be, which is 1 upon x plus 4. Just changing. So it is a way. This is a way. There is no theoretic thing. Okay, there is no theoretic thing. This is a way. This is a way to find the inverse. Okay. So inverse function for this one is going to be this one. So now I think summary is done, almost done, or not even almost.
Sir, can you repeat this again?
So this is, you have this function, no? And we want to find the inverse of it. So how we'll find the inverse? We will, what is that? Previously it were f of x is equal to one some variable, like this one is x, and in the variable of x. What we will try to make it? We'll try to make it x is equal to some function of some the expression in fx, like here. Previously it were function fx is equal to this expression in x, but I manipulated here. What I did inverse of like 1 upon f of x. This will get. So finally we got x is equal to some expression in fx. Now in place of x, just write g, or saying to be f inverse, and in place of fx, just write x. And finally, this is going to be your inverse function. That's all. Nothing more.
Okay, got it.
Okay. So so raise your hand one by one. I will take your doubt. So summary is done. Almost, not even almost, everything is done now. Okay. So let me take your doubt and we'll end the session now. So HV Singh is the first one. Hello. What's your good name first?
Sir Harshvardhan.
Yeah, hello Harsh.
Actually, I have doubt in activity 5.2.
5.2.
Yeah.
Which question?
Question number, I think, 3rd.
3. Okay.
Actually, I have doubt in last option, which is f of x is equals to 1 upon x. So how it is not decreasing our function? Because whenever we will increase the value of x, then automatically the value of f of x will be less.
Okay, which of the following are decreasing? So we seen that now it is a decreasing. No, it is a decreasing, and here is wrongness. No, this is actually decreasing. No, we just know that if 1 by x is there, so 1 by x is there, so it is actually with the calculus or in the graph, from the graph, it is clearly we seen that it is actually decreasing. So this is decreasing. There is a error in that.
Okay, sir. Thank you.
Sir, I have doubt in same question.
Yeah, please raise
Actually,
your hand. Please raise your hand. Okay, so in the same problem, in the same here.
yes, same.
What is your doubt?
Actually, the concept of one to one is my clear, but if questions are there, so there मतलब difficult हो जाता है solve करते हुए.
So no, I didn't get like.
Actually,
हाँ.
जब मैं सॉल्व करने लगता हूँ ना तो
हम्म.
मतलब हार्ड हो जाता है. कंसेप्ट तो मेरी क्लियर है, मतलब अभी ये जो फंक्शन है ना, इसको सॉल्व कैसे करना है.
अब जैसे प्रॉब्लम है और मुझे चेक करना है कौन सा फंक्शन इंक्रीजिंग है डिक्रीजिंग है, तो इसको कैसे चेक कर सकते हैं? बेटर इज
Hit and trial method, sir.
hit and trial, or graph is like all of
Also.
each function you can draw, right? This is a line, this is a line, right? This is a linear, this is a line, this is a
Yes.
quadratic, this is a x cube. These are very simple function. X cube is what? Exactly in this fashion. This is at least, so that's why the practice thing, you know
Yes,
the
sir.
concept,
That thing I know.
the concept, only need to do some practice. So here is at least your the lacking thing is that doing the practice. At least you have to, if you sit and solve some problem, you will know what is graph of some particular function like x cube, x square, x to the power 5. Some patterns you will see when the graph, when of such function, when n is odd, when once you do the more practice, when once you know that n is odd, then pattern is exactly the similar way. Even it is going
Yes,
to
sir.
be x to the power 2003. Even the same pattern, it is a bit steep, but same structure is there. If
Actually,
x is even, in the
if
even case is it is always a parabola shape. So there you can, from the graph it will clear, and now compare. No, just now I were comparing, how to compare that from the graph. It is easier. The first one
yes,
is what? A parabola. Already you spent 1 week on the parabola. If you see the first, this
yes,
is the
sir.
parabola. You spend it 1 week, and now easily you can draw the parabola also. And also it is very much clear. No, here is 4 is there, so you can draw the graph as it is a open upward.
Yes, sir.
So it is going to be somewhere shifted form open upward. But if it is open
And that will
upward,
fail
what you should do?
horizontal test. If
Sorry.
there, if it is a parabola, then it will fail a horizontal test, and that will
It
be
will
not.
fail the horizontal test.
Yes.
So after like if you draw the graph, it will be very easy and the function is not tough. No, if you are not able to draw the graph, then it
Sir,
will be
heat
actually
trial
a
method.
problem.
Excuse me, sir. Heat trial method. Put the value and.
That's the only way now. Then after it will remain hit and trial, nothing more.
Hit and trial is the
Oh.
best way.
Yes, and not even once you are doing hit and trial, and you have not only the 1 or 2, at least
Just
do 5 to 6.
one question, sir. Heat and trial solve the.
So hit and trial is what
Yes,
I
sir.
have to take some number. No, here for example I am taking, suppose, so what is that? You have this one, no, 4x square plus 4x plus 1. You have this function. So what is hit and trial? You will take some number, try to, this is x and this is your f of x. What is the hit and trial means? You will give some, for increasing you want to check. So put x is equal to 0, you will get 1. Put 1 here, you will get some number 9. And if you put -1, you will
Put
get some.
suppose sir put 0, then the value is a 1.
If you substitute here -1, then you will get here a
The
4
value
minus
is
4, and this is 1.
yes.
And if you substitute 2, then you will get some number -2. And from here, at least from this number, you can easily guess that, oh, how the pattern is, that it is increasing.
1, 2, 3, all positive numbers, then the increase graph.
Yes.
Yes, sir.
Yes.
A negative number, then decrease graph.
Decrease graph. And if it is increasing and decreasing, negative and positive in that case, so that's
Suppose,
why the slope is there, no? That's why the parabolic slope.
Sir, can you solve one question that will help us?
Yeah, so I'm solving now. No? Here is this one. I made some number, and now hit and trial. You will see that.
Excuse me, sir. Sir, put the value 0, then the value is a 1. 1 value 2, minus 1, then 1. Suppose that negative not x square, x cube value, ax cube plus 4x square plus 1. Then the value decrease, no?
Then again, you have to hit and trial. Then you have to go
Hit
with
and
the hit
trial,
and trial.
yeah, graphic.
So if you draw the, suppose 4x cube is there, plus
4x
4x plus 1. Sorry.
Yes.
If it
4x.
is this one, then see, this is a polynomial, no? And you are
Yes.
very much clear how to deal a polynomial.
Yes, polynomial.
So surely it will be somewhere root, and then how, in the behavior, how the end behavior is that it will go this side.
Sir,
And
0. Suppose, sir, turning point is cut the 0, but
so what is the end? So that is a polynomial. This should have at least one real root. Maybe it have two complex root, but at least it have one real root. So it could be like this. So if you draw this one, no, if you try to draw the graph, it will be very similar to x cube graph. It will be like that. I'm not sure about that, but it could be like that. Or maybe if it is 2 or 3 roots are there, so like this may go. I don't know how it could be. I'm not sure. But it is a kind of. But what is happening here? It is actually a increasing one. The reason is so that's why it is not very much clear. So in the positive, at least you will, some range you are able to decide that. In the positive case, always you will get a bigger
decrease.
and bigger
Increase.
increase.
Yes.
In a negative case, you will able to see a
Always
increase.
decrease.
No, in the
Negative
negative
case
case also it could be somewhere. So I'm not
decrease,
sure.
no,
You have
sir.
to deal with the polynomial way and try to graph it and see that it will be easier. Otherwise, see, that's why it will be algebraically, it will be difficult. Now there is more strong tool we want. So calculus now will come here. So
Actually,
don't
sir,
worry if you're
question, exam question and activity questions very different. Week 4 related question.
so in the quiz it were easier, no? It is not
Easier,
going.
but sir, question easier. I have selected and solved the another answer.
No, in the quiz, I think the questions are very easy, not even in compare of the graded one.
Yes, sir,
Graded is
graded.
tougher than quiz.
Yes, sir. I have understood for 3-4 weeks really higher the question level. But sir, one question
So let me
confused.
take now doubts. Okay. So that's the way you have to at least try to graph the function, then it will be easier. Otherwise, you have to know the calculus. That's the one tool, or sometime hit and trial may work. So next is Chinu. Hello Chinu.
Hello, sir.
Mm-hmm.
So I have a doubt, a couple of questions. First is 5.1, AQ 5.1, fourth question.
5.1 fourth problem.
So why is the fourth option false?
A function is called 1-to-1 if not equal to, then x1 not equal to x2. So remember, so what is the definition of 1-1? X1 equal, if we take x1, I am taking, so you have a function from a to b, and I am taking two x1 and x2 from domain such that x1 equal to x2. This implies f of x1 is equal to f of x2. This is for what? So this is one definition of domain, one case.
Yes, sir.
Otherwise, the another definition is what? F of, I'm taking 2 here, f of x1, okay, not equal to f of x2. This implies that x1 should not equal to f of x2. These two definitions we have.
Sir, first one should be opposite. Both should be opposite.
Opposite means what?
Sir, f of x1 should be if f of
So
x1
this
is
is
equal
no,
to.
this is not.
Yes, sir.
Here this is not case. I this is for checking well-defined function f of x1, f of x2 such that this is the case we have. This implies x1 is equal to x2. So this is for 1. I wrongly wrote here. That is case for the
Second is also should
So
also
second
be
is
opposite.
so it will be in the reverse form. So I will take the input, two different input, and their outputs should be different. That's the here.
Different.
Okay,
Different.
sir. So
This
it's
is the meaning of 1.
impli-
I wrongly wrote there. I sorry for that. So here is your outputs should be same. If it is happening, then their input is same. That's the implication is there.
Okay,
This
sir.
is one way.
Yes,
The
sir.
different way, if their inputs are different, their output should also different. It will never be the same. That's
Got
the
it,
here
sir.
one.
Sir, I have one more question. It's 5.2, fourth question again.
5.2, fourth question.
Sir, for the first option, like I know like we get 1x in like when we solve the equation, we get like something over x. So the graph will be 1 over x kind of graph. But is there a easier way to solve this? Some other way?
This is this one is enough. If you take this one, this will be easier. I already saw. So try with this one. This will be very easy with this way.
Sir, I have a same doubt in that question. Can you solve that question?
So I'm saying no. Try with this one. This will be makes easier to check this option.
So just like you are saying algebraically we should solve this, but like we can miss some points, no?
No, so what I'm saying, just take here the same. Let's do it here. So we have 4x plus 3. No, what is the function? 4x plus 3, 3x
minus 5.
Okay, where is that? 3x minus 5. Okay. So I'm taking two elements here from the domain. So this is 4x1 plus 3 upon 3x1 minus 5 such that their f of value, function value is same. So here is function value is 4x2 plus 3, 5, 3x2 minus 5. They are same. So we have this equation now. Let's do solve. So this is going to be 12x1, x2 minus 20x1. Okay. This is just multiplying here.
Yes.
So this is, I took 4 and multiplied with this one and this one. Now take 3. So this is going to be 9x2 and this is minus 15. Now this is going to be this side. So this is 12x1, x2 plus 9x1. I took this one and then multiplied both. And again, now multiplication, I hope it is clear. So this is 5x2 and this is minus 50. So this is going to be cancel out. This is 12 will be cancel out.
So minus 20x2 actually, sorry.
Sorry, minus 20.
x2, second last one, I think.
Second, okay, this is, okay, here is 20. Yes. So this is 20. So let's send it to this x1 with here. So this or this side.
Also cancels.
This side. So this is going to be and send this one to this side. So this is going to be at this 15 and this 15 will be cancel out. So this is going to be 34. X2 is equal to, this is going to be 29. Is there any wrongness? Let's see that here is 29.
Sir, it should be 29x2
Yes,
only.
29
First
x2
place.
equal to 29x1.
Sir, it's not 34. It's 29
Okay,
only.
it is not 29 will come. So this I don't know what is here. So that's why. So this is 20. No, oh sorry, this is 25. I'm looking. So this is 20.
I got it. I got it.
So this is x2 is equal to x1 finally got. So see that I took the function input same and finally I got x1 is equal to x1. This condition I got.
So just
So,
Sir, how you multiply this? 4x1 plus 3 multiply by 3x1 minus 5. That
cross multiply.
cross multiplication is there.
multiplication.
Sir, just a short question. The 1 over x you said is decreasing in previous question. So that's an error in the question, right?
Yes.
Okay, sir.
Okay, let me go with the
Excuse me,
next
sir.
one. Yes.
So that 1 upon x in that particular question is decreasing, is not decreasing, it is strictly decreasing. Like
Yes,
in
it is actually strictly decreasing.
yeah, so that's why that option is not.
No, I'm not. No, so decreasing and strictly that is ambiguous now. So decreasing means assume that it is decreasing means strictly decreasing and decreasing both is coming in that should happen. So oh okay sorry. So there is a difference in the video sir said is that.
Yes, sir. In the video also sir said like it is strictly decreasing because the equal sign is not there.
Okay, so if it is in the video, see, so for me, so till as of now, for me, I am saying, I assume that if it is decreasing means I used to take this sign, and strictly means this sign, exactly.
Yes, sir.
This is
Yes,
the I used to take, and if it is sir is saying the same, and if it is
Yes,
following
this
the
is
same,
the
that's why it is wrong option. Okay, that's why it is happening.
Sorry, can you explain the difference?
Sometime decreasing means also I used to take this one, but if it is in the video, sir is clearly mentioned that decreasing means this one and strictly means exactly that this sign is that, then you can say that option is going to be wrong now. That's why it is wrong.
So,
That
so
option.
let's say y is equal to 5 is decreasing, like because it stays constant.
So y is equal to 5 means this is a decreasing one, not
Even
strictly
if it is
decreasing.
constant, really. Okay. Okay, sir.
So if it is with the such case, so see, this is always thinking that decreasing is I used to be with that, and I never got such ambiguous thing that okay. So if it is decreasing means this one, and strictly decreasing means this one, and in the problem it says it is decreasing. That means I used to take, even you will, if you want, you can. That you can take with this sign, as I think sir is also said with the same way.
Okay, sir.
Okay, let me go with the next one.
Sir, what is the 5 divided by 3 rule in that question?
5 divided by?
Can you open that question? Yes, 5. Yes, 5 divided by
This is
3.
the domain, no? R minus that element you are removing, that 5 by 3. At 5 by 3, the function is not defined, no? Just substitute and check that. So that's why you are asking, no? Just so just check. In place of x, just write 5 by 3 and let me know what is the output.
Okay.
In the domain 5 by 3 is excluded.
Saurav is the next one. Hello, Saurav. Okay. Atharva is the next one. Hello, Atharva.
Yes, sir. All that my doubts are you solved that. Okay, no problem.
Okay. Next is last one. Okay. Any more is there? Okay. Next
Excuse me,
is.
sir. Yes, sir.
Hello, sir. Hello.
Yeah. Hello. Yes, sir.
Sir, one question, sir. Perpendicular related question, sir.
What is that problem?
Sir, actually, 2x plus 3y is equal to 2, and 3x plus 9y is equal to 7.
Okay.
Are the perpendicular, no? Sir, minus a by b1 and minus a2 by b2. This is
So let's
different.
do with the changing the slope intercept form. I'm not sure. Let's do it here. So y is equal to, it is going to be minus 2 by 3 and then plus 2 by 3. So this is going to be the our slope. Okay. And this is for this one, y is equal to minus 7 by 9x plus 7 by 9. So this is our slope. Now multiply this to minus 2 by 3 into minus 7 by 9. So what
The
we will
second should be minus 3 by 9.
Minus
9. Where is that? This is 9, no? So this is going to be, okay, here is, sorry, this is, yes. So this is 3 here. So this
Sir,
one is this.
1 by 3, no? Can cancel 1, 1, 3.
This
Minus
is,
3 by
just a minute. This is 7, no? What is here? 9.
3x plus 9y.
So this is, okay, this is fine. So this is 1 by 3, okay. So no issue. So this is the same I took. So this is minus 3 by 9 and this is 2 by 3. So finally we'll get here. What? This is cancel out. Okay, so just a minute.
Minus 2 upon minus 9, I think.
So we are not getting minus 1. So these two are not perpendicular.
Yes.
No, 2 are minus 1.
So we are here getting 2 by 9, which is not a minus 1. Okay.
Sir, one question is this R2 upon actually qualifier question, sir. Accuse one question, sir. Question number 15 and 16.
So what is the question? What is that question?
R2 ax square plus bx plus c, comma ax square plus cx plus b, a not is equal to 0, a comma b comma c, x belongs to R. Subset S, set of S. Use the information.
Okay,
This is
so
reflexive.
I'm not getting that. So can we wait because we wrote the solution now? I will give to upload tomorrow. Okay. So will that be okay if you see there?
Actually, it's a transitive relation, but answer correct is a symmetric relation. A, B, C, then the A comma B and B comma C and the A comma C. This is the transitive relation, no? A comma B and
It's
B
not
comma C or
transitive.
A comma C.
Yeah, so somebody
it's
is
not.
telling it is not transitive. Why it is so? You can explain him. Anybody was saying that it is not transitive. So can you explain him that to Saurav?
Sir, actually, I don't remember the exact question, but it's not transitive. That I know. It's only symmetric. R2 was symmetric, I guess, and R1 was reflexive, as far as I remember.
R1 reflexive, yes. R2 is symmetric.
Yeah, R2 was not transitive. That's for sure.
Why?
I don't remember the exact question, but it's not transitive.
Why
What
not
is that problem?
transitive?
Can you slowly speak that?
Sir,
I
I think
speak
it
very
was
fast.
like.
So what is that problem? Let me see it here now.
Sir,
What
wait,
is
I'll
Sir,
share the
AX square.
screenshot.
So let AX square
plus BX plus C, comma AX square plus CX plus B.
Okay.
A not is equal to B. A, B, C belongs to R. Subset S multiply S.
ABC belongs to R. Subset of S. So this is not symmetric.
Yes.
No?
Yes, sir.
So it is not symmetric, no?
Yes, sir. Not symmetric. But answer
So
correct.
you are saying transitive, no?
Yes.
No, it's transitive, sir. But sorry, it's symmetric, but it's not transitive.
So it is symmetric.
Yes.
It is not
because
transitive.
AX square plus only, yes, because C and B are only interchanged, so it would be symmetric.
No, so it is transitive or not?
No, it's not transitive.
Transitive
Not
means?
transitive means A comma B belongs to B comma C and A comma C.
See here, here is
I
if
think
it is.
fulfill no this condition.
So for example, suppose I am taking an example. Okay, so for the timing, let's take an example. 2x square, okay, plus 3x plus 1, okay, and another I am taking, okay. So again it will go 2x square plus x plus 3, okay, and another I am taking here 4x square plus 3x plus 1, and now it is going to be 4 square plus x plus 3. So see that this is A and this is B, okay, and okay, so this is going to be, let's again not 2,
This
here
is
is
a B and C.
let's stick here B, and
That's not the same. Ax square 2x square plus 3x. Actually ax square. 2
Sir,
3
sir, for R2 be transitive, it should be reflexive first, then only it can be transitive. Because A and like X and Z would be only in the relation when it is reflexive. And it is
that
not
is also
reflexive
true.
R2, so it's not transitive. It's only symmetric R2.
So checking the transitivity is that okay. I'm not sure that if it is reflexive, some relations are there which is
Yes,
not
I am
reflexive.
sure R1 is a reflexive, but R2 is a symmetric. I have not understood.
Okay, so
So that R1 and R2 belongs to as follow.
So what you are saying is that you are saying it is transitive or not. So let me clear that, is this transitive or not?
It is a transitive.
Okay, you are saying it is transitive, but answer is it is not transitive.
Yes, sir.
Okay.
Sir, I've
So
pasted the question in the chat. Sir,
sorry.
I've pasted the question in the chat, the whole question.
Okay. Okay. So okay, it is loading. So okay, so see that let's see that our problem is here that okay, this is the okay. I have to see in the chat, I think so. That I'm not sure. Okay, this is okay. R2 is ax square plus bx plus c, and ax square, just a swapping thing, abc belong and r belongs to, that's it. So it is that R2 is transitive or not. So let's check here that R2 is transitive or not. So we took two examples. I took this A and B. So I am taking, this is A is here and B is here. Okay. Now the same B is here and C could be different also, right? Is there any different we can give?
Yes, sir. Different.
What is the different here we can give here?
Sir, here A and C is not in R2. That's why it is not transitive.
Okay, let's say so see that here is A and this is now our C. Now let's compare AC. AC is our 2x square plus 3x plus 1, and here is 2x square plus x plus 3.
So you have taken the same function, A, B, and B, C.
Yes.
Okay.
2x square plus 3x, 2x square plus x3.
Okay, just let me just a minute. Okay, what is that? So I am taking this is the set of element where of R2 ax square plus bx plus c. This is one quadratic and this is another quadratic, ax square plus cx plus b, where a, b, c belongs to, yes, cross a, b, c and x belongs to R. Okay.
Sir, you just
Actually,
need to
this
swap
steps are
BC.
solution NCRT book. According, I have solved the not NCR, not symmetric. But I don't
Sir,
know
you just have to
symmetric.
swap BC. you have written like in the opposite manner, the BC pair, B comma C. It should be C
Yes.
comma B. 2x square plus x plus 3 should come first. In the
2x
second
square
pair.
plus 3x
2x.
plus 1. Here is what? 2x square plus, it is the correct, right? This is one.
Randomly value?
It doesn't
No,
matter,
sir.
I think.
Sir,
That thing.
AB
Why?
for AB,
Mhm.
B value is, and then for BC, B value you have written wrong. It should be 2x square plus x plus 3.
Oh,
But
here
you,
is that.
yeah.
So here is going to be x plus 3.
And C
Now
will
this is
be,
going to be swept form.
yeah.
So this is 3x plus 1. Now AC is going to be our 3x square plus 3x plus 1. Yeah, so okay. This is x square. Now it is same.
Yes, sir.
And here is the problem. That is also I wrote wrong and then stuck here. Okay, so this is not belongs to R2.
Not transitive, no, not symmetric, no, sir.
So this is not transitive. So this is happening. No, this is one element AB related to R2, BC related to R2. But when I took this is A and C, this is not in R2. Is that clear?
A belongs to B, B belongs to C. Oh, yes. Once two conditions satisfied, and the third condition not satisfied, not transitive.
Okay.
Oh my God.
Okay, next is Saruk is the next one. Hello, Saruk. What is the doubt?
Yes, sir. Sir, actually, sir, I have a doubt in activity 5.
Sir, this question, sir, R2 is a function.
Okay, now I am just saying that, okay, just try yourself. Okay, let's go ahead because this is a qualifier problem and I will post. Okay, I will give the solution. Once you see there, then okay, later we can see. That would be
Sir,
good.
any bonus mark provided?
No, there is no bonus mark. Why it is so? No. For
Actually,
the
sir,
qualifier.
previous term was student. I have
So
talking
if you are
to
term
and
student, then it would be that if you are doing the practice, then in the last the bonus mark is there. So add is the grading, no? Grading pattern is there. Just follow the pattern will follow the same. If you are
Actually, sir,
qualified, then if you are qualified student, there is no grade mark.
okay.
Actually, sir, I have a little doubt. Actually, I qualified in May term, and that time I choose two different subjects, and in this term I choose maths. But this term, maths quiz one is going. It's hard for me. So if my marks is for less than 40%, then I can give quiz two, na?
Yeah, you can give. I think
Okay.
yes, you can give. Yes, you can give actually.
Okay, then I will cover my marks in quiz too.
Yeah. Saruk is the hello Saruk.
Yeah. Yes, sir.
What?
Sir, actually, this in activity 5.5, sir.
Which question number?
Sir, question number 1 only. Sir, actually, this is not like a problem, but the problem is like I'm not understanding the continuous compounding. Sir has also discussed in the lecture also in 5.5. But the like continuous compounding, the interest rate calculation, there always a different formula given to use to calculate that particular question. So like how this works? That is my question.
This is the increase per year, no? And the share market is yearly increasing. That means here is a compound thing, no? Like what it means that suppose you are buying some. Okay, forget about this here. Okay, you bought a cloth of 100 rupees and 5% rate per year increase is there. So next year, what is the price going to be? 5 rupees, right? 100,
Yes,
5 rupees.
Okay. Yes, sir.
Now the increment will be 1 on 100. So per year increment is there. Continue and increase there. So that means your next year the price will 5% you will take off which number? 105 of 5%, not of the 100. So that is now the compoundly now increasing. No, once you added the that interest and then you are compounding it, then you are taking the increase rate. That means it's continuous increasing, means here the compound thing is happening. That's why the formula is that one. You are getting, no, let me again repeat it. Suppose your cloth is of 100 rupees. After 1 year, it would be 5% rate is there, increase rate is there, then it will be 105. Now, for the next year, you will take the 5% of what? 5 of 105 of 5, this one. And whatever you will get amount, you will add of that amount. And then finally, that is whatever the amount you will get, that is going to be the rate of in the second year. Sorry, in the second semester, in the second year. Second year, yes. This is now the compound thing. That's the meaning here, compound. Whatever your per year interest is there, the next year the interest will be on after adding that interest. Next year you will get the interest after adding this interest. Okay, this is the meaning of compound.
Got it, sir. After adding this interest, then only we will get that after second. Okay.
Yes.
Sir, one question was, sir, from the qualifier only, sir. So if I can ask.
Okay, what is the problem?
There is a question.
Maybe it quickly solved, then that would be good.
I can put it on the.
Okay, just post in chat.
So
okay,
it's not like only this question I am not able to solve.
Okay, post in chat. I will see later. So next is okay, Hers Vardhan again. Okay, hello Hers.
Yeah, sir. I have doubt in some activity questions.
Which activity?
5.3.
5.3.
Actually, question number 3. Actually, I am not able to solve it. Can you solve it?
Why it is so? Just break everything in 2 to the power and 3 to the power.
Yeah, actually, I'm trying to do that, but actually, I'm not getting right answer.
Oh, that's the error, no? That's
I
the
think
you are practicing, no?
calculation mistake.
The only the calculation, just everything, just break everything. Like 4, you will break into 2. 8 break into 2 to the power. 5 into 2 to the power. And what will come? No, it will come like this. Okay, so it will come like 2 to the power some number, 3 to the power same number, 5 to the power same number. So what it will come if you break? No, it will come as break and add for the 2 to the power, 3 to the power, and 5 to the power. Suppose same number 10 is coming, no? So 10 for each will come. And if it is this case is there, then it will be 2 into 3 into 5 to the power 10. And finally, if you add multiply, it is going to be what? This is 15 and 30 to the power 10 will come. Similar, whatever the number, I'm not sure what is that. What is the answer here? 60 or 30 is something.
16 power 50.
60 some will come here. So it is so here is 8 4. Maybe either it could be change everything in 4, or it could be you have to change in everything in 2 and 3. Once you do that, the power will be same to each number will come, and finally we'll multiply them, and then power will become. I'm just leaving that, but that is a number thing is there.
Okay, I will try. And if
just try
not
one.
I will ask again.
Besides the next, so you can ask this one in the TSS, and you can because this is just doing the
answer project.
Disha, hello Disha.
Hi sir. Sir, I have a doubt in activity 5.4, question number 4.
5.4, question number 5.4. Okay. Okay. This is in the behavior, no? In the behavior we just were talking about. What is your doubt here?
Sir, can you explain end behavior of exponential function?
So here is you have the exponential function again. This is exponential of 1 upon 7x plus 15. So forget about this 15. No, this is just a shift. If it is a each term here, whatever you will get, at 15 is there. That means if it is your graph is passing like this, then there is a shift or jump of 15 unit, and the exact the same you'll get. That's why forget about this one. Now we concern about this. So this is of what? 1/7 x is there, and 1/7 belongs to what? 0, 1 between. And you were there when I were discussing how the graph would be. In starting, we were there. So in such case, if your a belongs to 0 to 1, the graph would be like this. So how the end behavior? What it means that end behavior? What is the meaning of this case? What is end behavior meaning? As x goes to infinity, ax goes to
Infinity, sir.
it is going to infinite. Where it is going? Are you not able to are you able to guess this with the picture? No. What it means that? What it means that? Here, this sign, what it is telling?
Sir, I don't know.
Oh God. So okay, with the picture, if it is not, then how I can explain you? See, this means that this is the graph, no? This graph is continuously touching to this line. What it mean that? This distance, this is going to 0 means, right? This is the output. Continuously it is decreasing. So if you gone through the end behavior of polynomial, what it mean that? If it is going to be like this goes to infinite. If it is going to be like this is the asymptote. Means here it is continuously like this is going to be. What is there? It is continuously try to touch that x-axis, but not touching that. What it mean that this gap is continuously increasing or decreasing?
Decreasing.
This gap is continuously here is decreasing. What it mean that? This is the function value, no? It is smaller and smaller is happening. So that means ax goes to 0.
Okay, sir.
Sir,
I
can we
posted the
get your
question, sir.
email ID?
Sir,
Why you needed my email ID?
Sir,
excuse me,
if
sir.
there is doubt, we can ask you.
Even no, we have already discourses there and TAs are continuously there working on. So there is actually problem in the Google group is that automatic deleting the queries. I don't know, we'll try it and still that problem is there, that deleting automatically. So that's why the TAs are unable to answer. I don't know, but
Yes,
yeah,
sir.
discourse is there. Discourse is, if you are a qualifier student, then it will be problem. But if it is the discourse thing, so yeah, the thing is that okay, so I will talk to my TAs and I can give you my TAs
Sir,
mail
any
IDs
seat
and
problem this course?
sorry.
Any this course any yeah, valid seat, yeah, not any randomly all of people select.
The valid seat is, but you cannot access the, so there is no seat. That means finally you are not able to access when there is no seat. Seat means what? Seat means your Google seat you
Numbers
are
of
saying, or seat means
numbers
what?
of actually numbers of a student how to
So number, so there
participate
is no
in this.
limit of number. Sorry, I didn't get. So I thought maybe you are Google seat yourself. Okay, so seat means there is no limit of the number. There is no limit of a student.
So already so many of a student 2
Excuse me,
marks,
sir.
3 marks fail.
Yes,
Sir,
there is a
sir, I
who is
posted the question in the
okay,
chat.
okay. So if who is passing
So
this
can you please,
qualifier exam,
yeah.
all of you will get admission.
Oh.
That's shopkeeper problem. Okay, purchasing 160.
I
No,
know
so
when if I get the equation, then definitely I will get the answer. But the I think here English is the problem, sir.
So that's why the example is given. No? If shopkeeper acquires 160 item, the cost, for instance, that example is given. No? For instance, if a shopkeeper acquire 160 item, okay, the cost per clothing item would be what? Whatever the 1800 minus, what is the cost per? Previously it were 150, now, so now 160 items, so that means that difference 10 times. And how many clothes are there? 10, decrease by 10 rupees an exceeding number. What is the exceeding number? The exceeding number is 160 minus previous, now it is 160, previously 150 is there. So 10 times that. So let's make an equation now here. A retail shopkeeper is interested in purchasing clothes from a wholesale supplier. Okay. The price per clothing is 18, okay, 1800. If purchase is less than, if the number of items is less than 150, then per cloth, what is the cost or price? 1800. If it is, so what is that? Shopkeeper, no? Shopkeeper, a shopkeeper is there and wholesale is there. Whenever this shopkeeper is buying 150 or lesser than that, then per cloth price is 1800. And if the same shopkeeper buying more than 150, okay, more than 150, then there is a change in the price of per cloth. What is the change in price of per
It is
cloth?
1700.
So no, so it is not
No,
1700. That is
10,
example is
10
given.
10 rupees, 10 rupees.
Yeah, 10 rupees.
1800 minus 10 rupees decrease, and how much increase in the clothing? Suppose 170 is there, 170 cloth he bought, then how much increase in the number of cloth?
20,
20, right? So this is going to be per cloth price. Now you want to maximize or minimize, accordingly you can take. So what is that?
Can you please solve, repeat, sir?
So here is our problem is, just a minute, is that? So our problem is, let X be the number, represent the number of item he buys. Okay, so he buys, okay, so determine the value of X such that the amount paid by the retail shopkeeper to the wholesale supplier is maximum. So there is no issue. 1800 and 10 rupees decrease. What is the increase or decrease? No, what is that? Decrease is there. 10 rupees decrease into how many numbers? Into X minus 150. Right? This is the one cloth charge. Right? Because
Yes.
I said 170 is previously, then how much were it were? 170 minus 150. Now I'm saying, as the problem says, the X number of cloth is there, and suppose it is increasing, I want to minimize it, because in the case of lesser than that, the price is 1800. When it is greater than, then the price will decrease. That means surely X is greater than 150, right? Then the price will decrease.
Yes, sir.
That's why he will pay the minimum. That will be the profit. So here is X is going to be there. And this is finally the number of cloths is there. X number of cloth. And this is the per cloth charge.
Got it,
this
sir.
is
Thank
per
you, sir.
cloth charge or price and number of cloths. So total paid is there. This is the total paid, right?
Yes, sir. Thank you, sir.
Okay.
Sir, this time quiz is actually really hard. Midterm quiz is very easy to solve.
Yeah, midterm question related assignment. This term is a tricky, just a question. 2-3 question.
Only one question. I think this is the only problem I think tricky, but otherwise there is the problem is not tough.
Actually, sir, weightage week 4 weightage very high.
Yes, sir.
No, it is equally divided. I think, yeah, it is equally divided. There's
Actually,
no.
sir, function question only for one, and
So function
week.
is already in from the week one we have. From week one
Yes,
function, week
yes,
two
sir, yes,
function.
sir.
Oh, sorry,
Cardinality
week not
related question and
cardinality is that is that
two
sorry.
two question.
So
One question.
it is actually properly divided. It is not the very load. If it is the no mix up the you will see that the problem is look like on week four, but it is the mix of the concept. It is not
Oh,
exactly on week four weightage. It will be on the mix of the weightage. It surely will be problem asked on the cardinality. So cardinality of week one is there.
actually, sir, for 40% only for 2-3 marks lower than
Okay.
mathematics. You can provide any bonus? Yeah, not.
I'm not sure about how the administration is decided. I already
Actually,
reviewed.
I am sended mail because not na seat any criteria. You can qualify.
Just qualifying. There is no nothing. If it is the 1,000 or 10,000 student is passing, then everyone going to study.
Thanks
Okay.
to God,
10,000.
we qualified in mail. This hard question is come in May term. We will not qualified.
So in
Mate,
May term is I thought maybe May term is a bit tougher than this term is very easy. I'm not sure. So let's see that.
sir,
No,
May term
no,
actually
no.
previous term related almost question. This term is actually a cardinality related question. Yeah, uh, SSC related question. Pattern is a question different. This question is easy. I am satisfied, but pattern alike different.
So yeah, that's the one. Well, questions are not tough.
I
Pattern
Okay.
different
solved.
than almost all student different. The solution the provided according to question, but no randomly correct answer.
Mm-hmm.
I solved the
Okay.
mock size very easy
Even I
and
will say mock is tougher than our quiz.
no sir, mocks are easy.
No, mock is even tougher, I think.
Mo-
Mock have some more, if you see the SSC problem, it is
Mock,
tougher than
yes,
that.
yes.
So mock
Mock
is
is
tougher
hard.
than our quiz.
No, sir. Q is just a low, but exam time very mad
That the problem
disturbance.
is the exam time.
Yes,
Otherwise, the
sir.
problems are not tough. Okay,
Actually, I
and
am
because of the
actually
time
our
constraint is
exam
there.
exam very low question. Our confidence, sir. This answer. Okay, I am
Actually,
understood.
there is a
But
problem with
correct.
the time
But
constraint is there. Yes.
low question, very confidence. But
Mhm.
answer is wrong.
Okay. Okay. Thank you so much for joining. We'll see in the
Sir,
next.
can you share your
Sir,
email ID?
So don't. Otherwise, I will get more queries. So
sir,
I
sir
can
Shubham,
share the.
sir.
Please,
One
sir.
request, sir.
So
Humble
the thing
request,
is
sir.
like there is already forum is there. Post there. Let's see that how it could be. Okay. Post
Sir,
in the forum already. Discourse is there and Google group is there.
sir, one request, sir. Humble
Mhm.
request, sir.
Mhm.
Can you please talk to management team 2, 3, 4 marks, sir? Uh, Provided in bonus qualifier students, sir.
Okay.
Then qualified. So many students, sir. No me particular. Almost a student. Actually, not any seat criteria, no.
Mhm.
Why any problem?
Okay. Okay. We'll talk to team, operational team or administration. I am not
Oh,
sure, but let's see that.
okay, sir. Very helpful, sir.
Uh, and what about the yesterday session? Was it that good? Anyone is here who attended the yesterday session?
Yes, sir.
How
It's
was
good.
that? It were
I,
good.
yes, sir.
How that the doubt is as he was taking that is that well, and he is able to resolve all of the doubts.
Yes, sir.
Okay, that's fine. Okay, and what about the TA session? Anyone is there? Anyone attending some TA session? How's that?
Sir, it's good also.
Okay. Okay, maybe now there will be slightly change. Let's see how it could be. It could be some name will give me. Let's see that. Will inform you all of that how that the TS session will change some naming in the naming and will get will all of will get some different. Okay, we'll see. Thank you so much
Okay,
for
sir. Okay, sir. Thank you, sir. Good night.
good night to all of you.